Rule for derivatives, I did teach this to you last year in pre-calc at the end, okay? Normally what you're supposed to do is use the limit definition of find a derivative for a very long time, which for those who don't remember is the limit, you don't have to write this down, as h goes to 0 of f of x plus h minus f of x all over 8. Remember doing that? Oh, hi. You'd have to do this for literally every single problem. You'd have to plug x plus h in to x, simplify it out, and it's fine, but like when you get something like x to the 5th, can you imagine plugging in x plus h to the 5th power and trying, yeah, no. No, we don't want to do that. We want a trick. Here's the trick. The first rule is the constant rule, okay? Taking the derivative of a constant is very easy. The derivative of a constant is 0. Because when I say derivative, you say what? Slope. So if you were to graph like y equals 6, if you were to graph that line, doesn't it look like this?
0.
And the slope of a horizontal line is 0. So homework tonight, if you see like any number, you're going to write, well, the derivative is 0. You got to make sure you make that little notation because that's the derivative. Don't write y is 0, write notation. What? You have homework, but it's, again, this is not really due until next, I don't even know, Wednesday or Thursday. So, yeah. I'll talk about that more in a minute. F of x equals square root of 5. Even if it's square root of 5. Square root of 5 is still a number, is it not? What's its derivative?
0.
0. Okay? And this one people get wrong all the time too. D dx, remember that could just also be derivative. And then they could write a number next to it or a function next to it. People get this wrong all the time. 7 is a number, pi is a number, square pi is still a number. This whole thing is a number and its derivative is what?
0.
And you adjust, you don't have to write anything like prime, you just write equals 0. Okay? So, get this in your head, very important. The derivative of a constant is 0. Now, for what you've been waiting for, the very easiest thing, the simple power rule. The simple power rule is a formula to help you not use that long process thing. I am going to tell you, you do have to use this on the test, on one of the examples. You do have to do this on the test. For one, I'm not going to overkill it. The simple power rule, though, says the following. If I want to take the derivative of any x to a power function, so any x squared, x cubed, x4, whatever, the rule says to do the following. Take the exponent, multiply it in front. So wouldn't you agree this would be a 1 right here? 1 times n is n. X, then take your exponent and subtract 1. And it always works. Okay? Yeah, we did this last year. So let me give you some examples.
Would you keep the right thing for the goals?
No, you just write it.
Just write it?
Yeah, and let me give a couple. So f of x equals x squared, f of x equals 5x cubed, equals negative 3x and negative 4. F of x equals 3 over x squared. A lot of people get these wrong, so. Okay, so you will get, honestly, so fast at this. It's going to be great. It'll make me so happy. I can't wait. So we're going to find the derivative of x squared. Again, there's a 1 right here. The first thing you do is literally multiply those together. 1 times 2 is what? 2. Put the x after it, and then decrease this exponent by 1. So what would that be? 2x to the 1 or just? Done. You just found the derivative. All right, so then what would this one be right here? 5x cubed, what's the derivative? 15x squared, you just found the derivative, as opposed to putting the limit stuff. What about with negatives? Same thing. Negative 3x to the negative 4 is what? Not negative 12. Positive 12.
Yeah.
X to the minus 1 is what? Okay, I will not accept this. You must learn to write your exponents in positive form. Sorry. So where does that x to the negative 5 belong?
Bottom of the fraction.
12 over x to the 5th. Okay? Because -4 times -3. All right? Now, from this, could you then realize what you need to do here? Okay, so you first need to rewrite this as a, listen, I call it a monomial. To do a derivative correctly, you need to write it like a monomial, meaning a number of x power. A number x power, not number over x. So 3x to the -2. Now take the derivative. What would the derivative be? -6x to the -3, and then rewrite it back to being correct, which is -6 over x cubed. Done. Okay? This one people get wrong all the time.
Zero.
What do you think it is?
Zero. No, wait, one. Yeah.
Okay, so I'll show you here. Would you agree that right now there's a 1 here? There's a 1 here. Okay, again, the power rule says to do the following. 1 times 1 is 1. And then take away 1 is x to the 0, but anything to 0 power is, okay? So that's one way of looking at it. Here's another way. Isn't that in like mx plus b form? And isn't the slope of an mx plus b just the number in front? Remember, derivative, slope. So guess what this one? Thank you.
Yeah.
Okay, you are doing so great. What happens when I give you radicals?
Give us,
You got this, okay? Okay. F of x is 2 root x, and then f of x is cube root of 2x. I want to show you two different kind. Okay? So if you forget, again, the best way to do derivatives is number x power. Number x power. So couldn't I rewrite this to be 2x to the what power now?
1/2.
So now take a derivative. 1/2 times 2 is what?
1.
And you could write it there just for now. But take away 1 from 1/2. What's that? -1/2. Again, don't leave it like that. I want it written in as a positive exponent, so this would be 1 over square root of x. Now, I do not want you rationalizing it. This is where the funny part of math comes in. Because now in pre-calculus, I'm making them all rationalize, and I'm like, and now we stop rationalizing. Welcome. Don't rationalize ever again, correct? So you're done. Leave it like that. It's so much easier to find a slope that way, that's why. This one, okay? So let me show you this. Well, let me write this differently for you, just before we do this. Listen. When you have a number now under that radical, you kind of need to separate it. So this is really the cube root of 2 times the cube root of x. Would you agree? Do you see what I did, right? I'm multiplying, so it's the cube root of 2 times the cube root of x. Cube root of 2, isn't that just a number? Okay, so let's not even worry about that, but let's rewrite this as cube root of 2 times x to the 1/3. Since this is just a number, I can just multiply it with that exponent. And so cube root of 2 times 1/3 is just what? You don't know? No, we're not cubing it, we're multiplying it. We're multiplying it. It's the cube root of 2 over 3.
Yeah, that was next.
Do you see that or no?
No.
Okay, so if I had square root of 2 times 1/3, isn't that just square root of 2 on top, 3 on bottom? If I put a little cube root here, isn't it just cube root of 2 over 3? It's a number. You don't have to, you're not raising it to a power, you're multiplying. You're not raising it to a power. I'm not saying, hey, cube this, cube it right now. I'm saying multiply it by 1/3. Multiply this number by 1/3. What's 7 times 1/3? 7/3. What's the cube root of 7 times 1/3? Cube root of 7/3. Okay? All right, but then now take away 1. X to the what? -2/3. Okay, now rewrite this correctly. Tell me what belongs on top and what belongs on bottom. Well, this is obviously on top, cube root of 2. 3 is obviously on bottom. Where does that belong? On the bottom, and change it to a positive. Do I have to rewrite it as cube root of x squared? No, just leave it like that. I'm fine. I just want positive exponents. All right? Flip on over a few more examples and we're done. This is an easier, happy lesson. The final answer is cube root of 2 divided by 3x to the 2/3.
Okay, that's
Sorry, I know it's hard for my back people to see. More examples. I didn't really have a title for this one. We're just going to call it more examples. Let me write a bunch of them. Just trust me, they're going to go fast, but I got to give you a bunch of different ones so that way you'll be like, oh, this isn't hard. And then we'll do one more reason for doing this and we're done. More example. Okay, so you never want to leave things as a quotient. You want to leave things in terms of a monomial. And again, a monomial is a number, a letter next to it, to a power. A number, a letter next to it, and a power. So I'm not going to take a derivative until I rewrite this. Watch. This is a number, yes? Okay. So 5/2. A letter next to it. Well, the letter's on the bottom of a fraction right now, but I could move it up and write it as x to the what? -3. Oh, there I go. Now perform the derivative. What would the derivative power rule say? Well, what's -3 times 5/2? -15/2. X to the what power now? Take away 1. -4. Now just rewrite it with a positive exponent. Don't change the -15. Leave him up there. Leave 2 here. Where does x to the -4 now go?
2x to the 4th.
Done. You just found it. A number, a letter, an exponent. That's all you have to do, and you can do the power rule. So this. I don't like it right now. There's a squared mistake. Okay, let's clean it up. We can clean things up before we start. -7/9x squared. Oh, look at that. There's my number. X squared is on the bottom. Put it to the side and make it negative. You tell me what that is. See if you can fix that right now for me and write it correctly. Find that derivative for me. You don't know how to do fractions? You're making me nervous here.
I got it.
-7/9 times -2/1. You can't do a fraction? What's that? 14/9. Okay. And then this becomes x to the what power now? -3, which now belongs where? X to the 3rd.
We don't simplify.
Well, you can't simplify, I don't think. 14/9, right? Done.
Oh, yeah.
All right. Well, now, what if you had a polynomial? You do each one individually. And that's it. And you found the derivative. Rather than plugging in the x plus h and then cubing it, oh my gosh. Just take the derivative of each one. What's the derivative of 3x? Well, that's 3. What's the derivative of 2x cubed? Done. You just found the entire derivative. You just take each one individually. All right, so what about this one? What's the derivative of just x squared? 2x. What's the derivative of minus 2x? Include this minus 2. Now this one, again, you want to rewrite it. So this would be -2x to -4, which would then take the derivative would be what? 8x to the -5, which you would have to rewrite it to then. So your final answer is 2x minus 2 over 8x to the 5th. You take each one individually. No way. It's so much better. You have no idea. Like I'm saving you so much time. All right. Well, what if they give it to you like this? Well, what could you do right now? Starts with F, ends with oil.
Foil.
There we go.
Foil. Oil of what?
2x cubed minus an plus 8x squared minus an x, and then minus 4. I like to go in order. Now listen, did you take a derivative? No, you just FOILed, so be careful, because a lot of students will stop here and be like, there's my answer, and I'm like, no. Okay, take a derivative now, what do you get?
6x squared
Plus,
15x minus 1.
what is the derivative of a constant?
Minus 0. I'll be done.
Do you notice, can I just show you something? That every derivative degree of 3 went down to a degree of what?
2.
Every degree of 2 went down to a degree of, okay. So derivatives go down a degree. So when they ask you that question on that quiz 2.3 about which picture does match, if it's cubic, what's the derivative going to look like then? Quadratic. All right. Now, why are we doing this? Let me show you why and we're done. Find the slope of the tangent line. Write this down. Of f of x equals 3x squared plus 1, and write the equation of the tangent line at x equals 2. Remember that whole long sheet as you're writing this down, that worksheet that I gave to you where it was the 8 problems, you had to do like, okay, part A, find the slope of the secant line. Part B, find the slope of the tangent line when h is 0. Part C, now find slope at x equals 2. Then part D, remember that? It was like annoying, it was part A, B. We're literally gonna do it in like less than 30 seconds. Okay? So, slope is synonymous with what phrase?
Derivative.
We are going to find the derivative. 6x. Okay? Now, listen. That's not necessarily the slope. That's the formula to help us find the slope now at any point. And what's the point we got to work with? Well, 2. Plug 2 in. 6 times 2 is 12. That is the slope of the tangent line. You are now going to pick a point and write the line of the tangent. Well, unfortunately, they only give us 2. So how do I find a y? Put it back in the original. Don't put it back in here. I put it in here. You're an idiot. You're going to get 12 again. I put it here. I'm just like, why are you doing that? Put it in the original. If you plug 2 in right now, what are you going to get out? 13, is that right? Okay. So my point is 213. My slope is 12. You're going to write an equation for the line. Y minus y1 equals m times x minus x1. Y minus 13 equals 12 times x minus 2. And then obviously solve it. For those who need the visual, because I think it's important that you understand the visual part of this. Okay? You have a quadratic that's shifted up 1. It's kind of skinny. Okay? Are you with me so far, right? At the point 2, which is right here, that y value is what? What's that y value? 13. And if you were to draw a tangent line, it would go like this. And the slope of that tangent line is 12. And the equation of that line is 12x minus 11. And that's what you have just done. You have found the instantaneous rate now at the point 2. You can do this now to any point. You can use that formula right now to find it at any point. Welcome. Now, what do I want you to do? I want you to have a Shabbat Shalom, obviously. Shabbat.
You're still recording on